Okay, so we're going to start this chapter 10 in class 10 maths. Okay, some applications of trigonometry, and the first portion will be the test 9.1A, which includes the exercise. Okay, here exercise 9.1 and introduction, start with that, and B1 2 3 4 question. All these questions are on page 213. Okay, video 1. Now we'll start with the introduction. This chapter is mainly to deal with heights and distances. Okay, now what do we mean by that? Look here, there are many uh, structures, like for example the TV tower in KOHIMA Science College, which are quite tall, so tall that it is virtually impossible to measure directly with a measuring tape, right? So, and then there are distances like the width of a huge river like Brahmaputra, where it is virtually impossible to measure directly the breadth of the river. So in those kind of cases, we measure them indirectly. Okay, we can measure them indirectly by using our knowledge of trigonometry. So that is all about heights and distances. Now in these heights and distances, there are three basic concepts, okay, that we need to be very clear about right from the beginning. And if you get this clearly, then the solving part will be easy, okay, rather easy and manageable. So let us go through them, carefully listening to what we're going to do here. It's quite simple. Now here, instead of reading the definition, let us do an activity. You can follow it with me. Draw it like I'm going to do it. And look here, let us say this is your eye. Let us say this represents your eye. What? The letter E here represents your eye. The dot is your eye, let us say. And then you think of an object that you will look above your eye level. Think. Yes, a bird on a tree. Okay, so let us take that. This bird, this point bird, is on a tree. So what you're looking on the bird here is called the object. So if you look at a star in the sky, then the star becomes your object, right? So right now our object is the bird, so which is above your eye level. So join your eye to the object, the bird. Such a line joining your eye to the object you're looking at is called the line of sight. So this concept, first one, is what is line of sight is clear now, right? Now let us draw through your eye again another line. What kind of a line? A line that is parallel to the floor of your room. Now if you notice your floor of your room, then it is not inclined like a mountain. It is always flat. That surface is called horizontal plane or a horizontal line. So draw a line through your eye which is parallel to the floor of your room. Okay, such a line is called horizontal line, or we simply call it as horizontal. So here the angle formed by your line of sight. Now when you take this activity, treat it like I am looking at a bird. You imagine like that. The line horizontal is drawn through my eye. So use personal pronouns like I, me, not mine. I'm doing this. Then learning becomes easier, like right when you bring it to your personal pronoun, right? So here use those words and you'll find it interesting also. So here the angle between the line of sight and the horizontal passing through your eye, this angle, when the object, if the object is above your eye level, then that angle will be called your angle of elevation. That means elevation means you're looking at an object above your eye level. Simple, right? So now pause the video and write question number 1, 2, and answers also, and draw the diagram, and come back and replay and go to question number 3. So here, question number 3. Now I'm going to go to the third concept. What is angle of depression? First one, line of sight. Second question, angle of elevation. And now, angle of depression. Okay, write down the question and then wait for the definition. And then near your question number 3, let us draw a new diagram. Let us say, just like we took just now, this represents your eye. Which one? The letter E here, which is a dot, represents your eye. Now, this time you think about the reverse. Think of an object that is below your eye level. Take an example from your daily life. Don't think too much beyond that, okay? So, okay, think, try. Yeah? Yes, that's right. a fish in a pond. That's very good. A fish in a pond would definitely be something you will look down below your eye level, because the fishery pond is not in the sky, isn't it? It's on the ground, so you have to look down. So that's below your eye level. That's correct. Let us say this point represents the fish. So join your eye to the fish, which is the point here. We know now, we have already learned this. This is your line of sight. Or you can say, this is my line of sight. Use personal pronouns. It becomes interesting, right? So draw a line parallel through your eye, parallel to the floor of your room, and you know that is called your horizontal line, or we can simply call it as horizontal also. So the angle formed between this horizontal and your line of sight, when your object, the fish, which is below your eye level, then such an angle is called angle of depression. So depression is the exact opposite situation to your elevation, right? So now what is angle of depression? Let us read through this definition. It should not be so different from the elevation except for one or two words. Let us see what is the main difference. The angle formed between the line of sight and the horizontal passing through the eye of the observer up to here will be same. When the object is above, now it has to be changed that to below. When it is depression, below what? Below the eye level or below my eye level is called angle of, and we have to replace elevation by depression. So we have to be very clear with these three concepts: line of sight, angle of elevation, and angle of depression. And then the solving part will not be so difficult. Well, one more thing before we start the exercise, right before we start the exercise, I want to mention this, so you write down along with me. Remember this, and it will make it easier for you as well. So here, in every question in exercise 9.1, almost every question, you will find one or more right triangles appearing. Okay, right triangle means one angle is 90 degrees. Let us label it as ABC, for example. You will almost invariably, almost all the time, find out that one of the acute angle, acute means this is 90, the other two are less than 90. So any angle lesser than 90 degree, okay, is called acute. So either this or this will be given. Normally one of them, 30 degree or 45 degree, whatever. If one angle is given and any one side, let us say the level of the ground is given 9 meter. So one side BC is given, one angle C is given. And surely you can find the two unknown sides AB and AC very easily. How? By using the knowledge of trigonometry. That is the trigonometric ratio, sine, cos, tan, right? Sine 45, 1 by root 3, all those things you can use to find out the two unknown sides easily. Keep that in your mind, okay, as we do the numerical. I repeat, one side will be given and one acute angle will be normally given. And the two unknown sides can be easily found out by trigonometry. That's what you're going to do in this exercise 9.1. Let us start. Now B1 is the first question. So write it down on your notebook. B1. I hope you're doing with me, right? Let me read the question for us. Here the question reads, a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of the vertical pole to the ground. Find the height of the pole if the angle met by the rope with the ground level is 30 degrees. Read the question clearly and then start doing it. So there is a pole. Let us imagine this pole to be AB, securely put on the ground. So this height of the pole is unknown. The question says you find out. The question is saying like that. But there is a clue given to us that is at the top of the pole A rope has been tightly stretched and tied to a point C on the ground. This is the ground level. So this will be 90, obviously. And the question gives us the clue that this length of the rope is, let's see, is 20 meters. And the angle met by this rope with the ground level here is 30 degrees. As I said, one angle given, one side given, you can easily find out the height of the pole. So let us start here in the figure that we have drawn just now. We have here AB equal to question mark representing the height of the vertical pole. The word vertical means making 90 degrees to the horizontal ground. Okay. Then AC is 20 meter. Okay, this is the length. Okay, length of the rope that we are tying to the top. And then here angle ACB is 30, sorry, it is 30 degree. This is nothing but, according to the language of the text, making an angle of 30 degree with it. So this is the angle, okay, this is nothing but the angle met, M-A-D, by the rope, okay, with the ground, okay, with the ground, this 30 degree. So with this information, we're going to have to find AB. As we'll say just before we started, in one or two right triangle will be given, in this case right triangle ABC. So when you want to find the unknown side, put the unknown one, the one you want to find AB, height of the pole, on the numerator. This is not a rule. I find this way easier, and then the side which is given to you down here, AC. So that is compared to 30 degree, opposite by hypotenuse. What is the name of that ratio? Yes, that's good. That is sine, right? Sine 30 degree. So proceed, and then AB we are trying to find out. AC is 20 meter, very clearly here. See, AC 20, even here also. So that is sine 30, we know from our table, right? In our previous chapters that it is 1 by 2. The value is 1 by 2. So next step, just go on, and that implies don't move the AB, just keep it on the numerator. And denominator 20 you shift means to the right side, means it will go up to the numerator. So 20 ones are 20 divided by 2, and meter also will come up along with the 20. 2 ones are 2 and 10s are 20, so that is 10 meter. So the height, if you want to write, height of the pole, or this pole, whatever you like to write, AB is equal to 10 meter. You can as well stop here also if you want. Okay, so let us go to the next question, that is B2. Okay, write it down on your copy, B2. Let me read the question. A tree breaks due to a storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree with it. The distance between the foot of the tree, listen carefully, to the point where the top touches the ground is 8 meter. Find the height of the tree. Okay, find the height of the tree. So you would imagine there was a tree. Before it was broken, it was straight up like this, straight up, upright, broken part. So let us say AB after breaking is the unbroken part, and this is C dash, let us say. So this AC dash portion fell down and struck the ground here, making an angle of 30 degree with the ground. Question clearly says that. So this will be this broken part now on the ground. Then the distance between the foot of the tree and the point where the top broken part touches the ground is clearly mentioned as 8 meter. Clear? Now you would know that tree will be vertical to the ground, so 90 degree. Vertical means 90 degree. So you have to find the height of the tree, means original height before it broke. So this is AB and AC. If you join, that's the original height. So AB and AC you have to find. So in the figure here, we write AB is question mark, is the unbroken part, sorry, unbroken part, okay, unbroken part. And then AC is question mark, the broken part, the broken part. Now we write here AB plus AC, therefore will be equal to question mark the height. The question is asking this height of the tree. In a sense, they mean to say the original height before it broke down. Okay. Now this angle ACB, so you write your angle ACB is equal to 30 degree. Is nothing but angle. Okay, angle according to the language of the text, met by the broken part, met by the broken part of the tree. That means broken part with the ground. Okay, with the ground. One more thing, we can just insert it here in this space, is this one, BC. BC is 8 meter. That is the distance at which the top, okay, the distance or between the foot of the tree. Okay, let's just use the same language, distance between the foot of the tree distance between the foot of the tree to the point where the top touches the ground. To the point, okay, to the point, please write it, okay, yourself, where the top touches the ground. You complete the one, okay. Now with this information you have to find AB and SC and then add them. That will give you the height of the tree. As we said in the beginning, one angle is known, one side is known. Very easy to find the two unknown. So just start with the right triangle. In right triangle ABC, you would imagine like that. In right triangle ABC, here we want to find AB unknown. By the unknown is BC 8, that is 10 because it is opposite by adjacent. So this is nothing but 10 30 degree. So here AB by BC, very clearly BC is 8 meter. You can see it here also and here also. So 1030 value is root 3, so we put it like that. Now we just put AB on the numerator, shift the denominator, it will go up and multiply the numerator 1. So 8 by root 3 and meter also will come out. We learned this from our previous chapter that when there is an irrational number in the denominator, we remove it or rationalize the denominator. How do we do that? We write the same number and multiply whatever root 2, then root 2, root 3 here. So same one you put up and down. Then the denominator will get the root removed. So that will be equal to 8 root 3. When you multiply 8 to root 3, divided by root 3 into root 3 is 3 and meter. We may keep this one as equation 1. Then, and in the same triangle, we found AB now, we want to find AC, the broken part. So AC by, the given one is BC. So AC by BC is nothing but hypotenuse by base. So hypotenuse by base or adjacent. So that is sec, right? Because that's the name of the ratio, sec, and the angle is 30 degrees. So as we proceed, we get here AC by BC is 8 meter is equal to cos 30 is root 3 by 2. So reciprocal is sec, so 2 by root 3. As we proceed and keep on doing, we will get here AC don't move, then equal to, then 8 will go up, 8 to the 16 divided by root 3 meter. As we said, 16 by root 3, we need to remove this irrational number. So same irrational number you will multiply. That's the trick in removing it. And so that will give you 16 in the root 3, 16 root 3 by root 3 in the root 3 is 3 and here meter, right? Now once we are through with that, keep this one as equation number 2. Therefore, you can write here height of tree. Height of tree, that the question is asking, comma, which is AB plus AC will be equal to AB here in equation 1 is 8 root 3. So we write the one 8 root 3 divided by 3 plus here AC, just now we got it, 16 root 3 by 3. And we can put a bracket and put meter here as a common taking out. Okay, so then we can solve this 3 and 3 LCM 3. Then here 3 ones are 3, 1 into 8 root 3, 8 root 3 plus similarly 1 into 16 root 3. So this much meter. Now if you observe this one carefully, it looks something very similar to 8x plus 16x, meaning 8 root 3, 16 root 3, root 3 is like the x. So 8x plus 16x is 8 plus 16. So 8 plus 16 is 24 and root 3 divided by 3. So once you do that meter here, 8 3 ones are 3, 3 8s are 24. So the height of the tree before it was broken was 8 root 3 meter, right? 8 root 3 meter. Now we'll go to B3 now, having done B2. I hope that is clear to you, okay? So here B3. So in B3, let me read the question for us. A contractor plans to install 2 slides for children to play in the park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meters. So let us deal with that. And is inclined at an angle of 30 degrees to the ground. So that's for smaller children. So let us say this is a slide. A shorter height for safety, I believe, 1.5 meter. The top of the slide A, bottom is B, and the slide is coming down, making 30 degree with the ground. And let us say this is C. So it should be 90 degree here. And the question is saying, what is the length of the slide, means AC. So in the figure that we have drawn just now, here AB is equal to 1.5 meter. It's nothing but the height of the slide above the ground. Okay, so that is the one. So this is case 1. Okay, just right here before that case. Okay, I think this part can be wrapped up now. So we can just write here case 1. So case, this is your case 1. Case 1. So in the figure in case 1, here AB is 1.5. Then we write here AC is a question mark, is the length of the slide. The length of the slide, which the question is asking us, DE, okay? Slide, sorry, just let me write once more, slide. Then angle ACB is equal to 30 degree. This is the, you can just write simple angle at which slide is inclined. The word inclined means making angle, okay, inclined to the ground. So just keep it in short. So we have to find the length of the slide AC. So you take the right triangle. So in right triangle ABC here, we have the length of slide 1. Find numerator is better, I say it like that. It's not a rule though. By the known side AB is hypotenuse by opposite. No? Hypotenuse by opposite is nothing but cosec. Angle is 30 degree, right? So that gives you AC by AB is 1.5 meter. And sine 30 is half, so cosec will be reciprocal 2 by 1. So 2 by 1 means simply, you just write 2. So AC will be equal to 1.5 into 2 is 30. 1 decimal, so point here, 3 meter, that means. So that's your answer. The length of the slide is 3 meter. You can write it or you can just stop it there. Now next, case 2. So B3, case 2. In this case for elder children. So let us read the second sentence of the text and you will find out there. It says, whereas for older children, she wants to have a steep slide because they are older children, safer, at a height of 3 meter, double the height and incline at 60 degree to the ground. What should be the length of the slide in this case? So let us say this is the taller slide. Making here 3 meter, okay, 3 meter. So 3 meter is the distance. So here, excuse me, now here, 3 meters. So AC is, the height is, let us say PQ this time. And at a point on the ground, the slide comes down. Okay, the slide comes down with making an angle of this time only huge angle 60 degree because the children are older, so safer for them, I think, PQR. So we have to find the length of the slide PR now. PQR. Okay, so this obviously should make 90 degree, right, to the ground. Now here in the figure, means in this figure, PQ is equal to question mark. No, not question mark, sorry. PQ is equal to 3 meter is the height of slide for the older children, elder children. Then PR is a question mark. This is nothing but this is the length, okay, the length of the slide that we need to find out. Then angle PRQ is equal to 60 degree. So this is nothing but the angle at which slide is inclined, okay, inclined to the ground. So with this information, we have to find out the length of the slide. So in right triangle PQR this time, here the length of the slide PR by given side PQ is hypotenuse by opposite again. That is again cosec, but this time the angle is 60 degrees. So as we keep on doing this, next step, PR don't shift. Then PQ, PR by PQ is 3 meter. Put it once before you shift. cosec 60, okay, sine 60 is root 3 by 2, so this will be 2 by root 3. So you shift, put this PR, don't shift that, and then you shift this 3 to the other side and go up and multiply 2. 3 2s are 6 by root 3 meter. As we have been doing by now, we have to remove this irrational number root 3. So let us remove that by multiplying by root 3 up and down, and that gives you 6 root 3 by root 3 into root 3, 3 meters. So 3 2s are 6. So the length of the slide in the second case is 2 root 3 meter, right? Now we'll go to the next question, B3, the last question for this test portion. So you get ready for that and write on your note B4. B3 is done just now, right? B4, page 214. Okay. Okay, let me read the question for us. Question B4, the last question. The angle of elevation of the top of a tower from a point on the ground which is 30 meters away from the foot of the tower is 30 degrees. Find the height of the tower. There is an elevation happening here. So there is a tower. You can just draw that tower. Let's say the tower is top A and B, and at a distance of around 30 meters away from the foot, a person is standing at a position, let us say C. And from that, this is his eye, therefore C. Join to where he's looking. Look into your question. He says the top of the tower, elevation of the top. That means he's looking at the top of the tower, his line of sight, and the horizontal line. So this is 30 degrees. So as I said, heights and distances. You cannot measure this pole directly because it's too tall. So you're measuring the angle by using line of sight and going to calculate by using trigonometry. Instead of measuring directly, you're doing indirectly by using trigonometry and calculating, right? Instead of measuring that, because it's too tall, right? So here we can write here in the figure here, this height of the pole is what they're asking. AB is equal to question mark. The question mentions this one as tower, sorry, not pole. Height of the tower, that is what the question is asking. Height of tower. Then BC is equal to 30 meters. This is nothing but distance away. Okay, so you can just write in short, distance from the foot, okay, foot of the tower, distance from the foot of the tower at which the observer, the person looking at the observer, stands. The observer is standing, that means, okay, stands. S-T-A-N-D-S. So with this, angle of elevation, one is there. From point C, he look at the top of the tower's elevation, and the angle is angle ACB, 30 degrees. This is the angle of elevation. We have to find the height of the tower. So I just write here in right triangle ABC. The height of the tower you want to find on numerator. The one given is not AC, BC. So write that BC known down. So opposite by adjacent, that is 10. Angle is clearly 30 degrees. So here AB by BC is 30 meters, and 10 30 is 1 by root 3. So the value is like that. See here, BC is 30, so we replace by 30. Then don't move the AB, the height of the tower. Denominator 30 shifted to right, go up, multiply 1, 30 by root 3. We need to remove this irrational number root 3 sign, root sign. How do we do that? We have been doing enough number of times. So root 3, same one, up and down you put. Then 30 root 3 is 30 root 3 meter. Divided by root 3, and the root 3 is 3. 3 tens are 30. So 10 root 3 meter is the height of the tower. So this concludes the portion for the 9.1A test. They're quite easy, okay? Every question in that test will be identical to these questions, but number may be changed. Like 30 here, but there it may be 15, and here 30, but there it may be 45. So you can look and compare and solve. So it's quite easy. It's good practice, right? Okay.